to the video. Here's the problem we're looking at. It's a situation with a deck of cards. Notice that this deck of cards is different than the deck of cards we've seen in some other earlier questions in other sections. This deck of cards, they're only using 52 cards. They've taken out those two jokers. So the total number of cards here is 52 cards. And if we read through, it'll describe how those 50 cards, what they're composed of 13 of each suit, spades, clubs, hearts, and diamonds. 2 of those suits are black, 2 are red, and here's the specific cards in each color and suit. So the first thing they ask us is, what's the probability that the card drawn is a 7? So to calculate this, the probability that we draw a 7, remember now that 7, that number 7 is talking about the actual number on the face of the card. So the picture on the face of the card is a 7. And we can think about, to find this probability, we can think about it as the number of outcomes that make up this event divided by the total number of events in the sample space. So what are the outcomes that make up, we draw 7? Well, that's the number of ways to draw 7, or the number of 7s in the deck. Divided by the total number of cards in the deck. So the total number of cards in the deck is our sample space, essentially. So the number of outcomes in our sample space we saw is 52, so that will be our denominator. And the number of 7s in the deck, well, they don't have them listed here, but that dot, dot, dot means the numbers continue. So there'll be a 7 of spades, a 7 of clubs, a 7 of hearts, and a 7 of diamonds. There's 4 7s altogether. So 4 out of 52 would be our answer here. Notice they asked don't enter it as a decimal, so we're just going to put it right in there as 4, and then the fraction slash key, 52. Alright, let's look at the next part here. Now they're asking, the card drawn is a face card, and just to be clear, they define that as a jack, a king, oh, stopped writing, let's try again, a jack, there we go, as a jack, a king, or a queen. So to calculate this, we need to know the number of face cards. So we're at the R in cards, divided by total number of cards. So we already know our total number of cards in the deck is 52. To find the number of face cards, we can see there's 3 face cards, jack, king, and queen of each suit. So it's going to be 3 times 4, so there's 12 face cards altogether. So 12 out of 52 is the probability of getting a face card. And notice this fraction could be reduced, but the question doesn't require it. We can go ahead and enter it as 12 over 52. Alright, and let's now look at the third part of that question that's got an interesting key vocab word there. It has the word not in it. They want to know the probability that the card drawn is not a face card. So we could do this in the same manner. We could calculate the number of cards that aren't face cards and divide that by the total number of cards. Whenever we see that keyword not, there's often a faster way to get at the answer. So we can remember that rule of complements, which tells us the probability of something not happening is 1 minus the probability that it does. So the probability of getting not a face card, to do that, we can do 1 minus, equals, sorry, let me be more clear. Erase that, equals 1 minus the probability that we do get a face card. I'm in trouble with my pen, sorry. 1 minus probability that we do get a face card. And we already found in the previous problem the probability of getting a face card is 12 over 52. I'm just going to continue this up at the top up here. So it's going to be 1 minus 12 over 52. So we could do that in a number of ways, but if we want to make like fractions there, we can say it's 52 over 52 minus 12 over 52, which gives me 40 over 52. I can go and enter that right there. So there's a 40 out of 52 is the probability of not getting a face card. If we want to see what that would be just as a decimal, just for fun, it's about 0.769, so about 77% chance of not getting a face card. So these are all calculations that anyone who's doing gambling or trying to make money off of playing cards is doing all the time to assess their likelihood of winning based on making this decision or that decision in a card game. One common error in these problems that I'd just like to point out for you to kind of put a note on your page, keep in mind as you go into the test, a common error that I see students sometimes make on exams and homework is that they'll calculate that numerator, the 4, the 12, or the 40, but they'll forget the denominator. Because the denominator is not really changing from time to time, it may not attract our attention. One thing I'd like you always to do, or a helpful tip can be whenever you're entering an answer that's a probability, remember before you begin, a probability has to be between 0 and 1. So if a question asks you to calculate a probability, you know ahead of time your answer has to be between 0 and 1. So if you come up with an answer of 4, look back and say, oh, it had to be a probability. I know I did something wrong. That 4 need to be divided by something. And that can be a helpful tip. Okay, thanks.